Today we will talk about rational algebraic expressions. This is section 5-4 in your textbook. The essential question for this section is, how do you simplify rational algebraic expressions? To start off, we really need to understand what is a rational algebraic expression. Well, basically, it is a rational expression, and a rational expression is basically another name for a fraction. But it's a rational expression that can be expressed as the quotient of polynomials. So the numerator is going to be a polynomial, the denominator is going to be a polynomial. So two examples of rational algebraic expressions might be 4x y squared over 7y, or x squared minus 3x minus 4 over x squared minus 1. So these are typical algebraic expressions. Now, what we're going to try to understand in this section, though, is how do we go about simplifying them. So let's look at some examples. So let's look at this. See if we can simplify x squared minus 2x over x squared minus 4. Okay, what we're going to do initially is factor both the numerator and the denominator and see if anything cancels out. So if we look at the numerator, we've got something common. We can take an x out, which leaves me with x minus x times x minus 2. Then if I look at the denominator, I've got the difference of squares, so that's x plus 2 times x minus 2. And notice I have an x minus 2 in the top and the bottom, so I can cancel those out. And what am I left with? I'm left with simply x over x plus 2. So this is one example of simplifying a rational algebraic expression. So we've talked about rational expressions. Well, what about a rational function? This would just be the case where we'd have a rational algebraic expression and set it equal to f of x, which would yield a rational function. And it would look something like this. F of x equals 2x squared minus 7x plus 3 over x cubed plus x squared minus 2x. All right, and let's say we were asked to first find the domain and then to find the zeros of this function. All right, in either case, however, what we want to do is we want to factor out the numerator and the denominator and see what we end up with. So if we factor the numerator, let's see what we get. Okay, so equals. And so the numerator is going to end up being 2x minus 1 times x minus 3. Now if I factor the denominator, I've got a common term x, and then that gives me a trinomial which I can similarly factor. And bottom line is we're going to end up with something that looks like this. We're going to end up with x times x minus 1 times x plus 2. Okay, so first of all, we're going to look for the domain. The domain is what are the possible values that x can have for this function. Well, if you look at the numerator, x can be anything. But if you look at the denominator, you realize that there are certain values that x cannot be. Specifically, x cannot be 0, because that would make the denominator 0. So x cannot equal 0. X cannot equal plus 1. And x cannot equal minus 2. So therefore, the domain is all values of x except 0, 1, and minus 2. All right, now the zeros, or the solution of this, is basically when we set the function equal to 0 and we solve for it. Well, if we set the function equal to 0, that means the numerator is going to equal 0, and that means each term of the numerator has to equal 0. So first of all, we're going to have 2x minus 1 equals 0, and then we're going to have x minus 3 equals 0. So to get the zeros, first we're going to set 2x minus 1 equal to 0. And if we solve for x, add 1 and divide by 2, we get x is equal to 1/2. So this is one of the zeros. And if we set x minus 3 equal to 0, and add 3 to both sides, we get x equals 3. So the two zeros are x equals 1/2 and x equals 3. And as I said, the domain is all values of x except 0, 1, and minus 2. All right, now I'd like you to go to page 228 in your textbook and do oral exercises numbers 2, 4, 6, 8, 10, and 12, and post your answers in the drop box. Thank you.